Hi all, welcome back to the Security and Privacy in Cloud and myself Jay Lavanya, Assistant Professor of CSE Department. And so today we are going to see Unit 2. The title is that Security Design and Architecture for Cloud. Under this particular topic unit, we are going to see security design principles for cloud computing and comprehensive data protection. So let us see one by one. So what is meant by security design principles in cloud computing? So this security design principles for cloud computing, which helps to ensure the cloud environments which remains resilient against the threats while maintaining confidentiality, integrity, and availability. And also, if you take the security pillar, includes the ability to protect information system and assets while delivering business values through risk assessments and mitigation strategies. The security pillar provides an overview of design principles, the best practices, and the questions which is applied over the cloud. So let us see one by one. So what are the principles which is available in. So here in this diagram, you can able to see what are the things comes under the cloud design principles. So totally there are 6 design principles which is illustrated in a diagrammatic format. Automation, which in which you can cloud computing, the process or the involvement which you are going to use or which you are going to perform the task will be automated. Scalability based on the resources available, the task will be extra, it can able to infinitely, you can able to expand, that is scalability. And resiliency is nothing but the base which is available 24/7. And next is that security. So this is aspect, the title is security, right? So Helen, under this cloud design, the security plays a major role here in this cloud. And performance. So performance, if you take like based on the routine work you're providing to the particular task, it will be performed. So that is the performance. And cost optimization. So under what kind of going to optimize the resources or the task in which the user or the client will be provided, the cost will be negotiated and it can be reduced. So this is all about the cloud design principles, which is a basic, the common, which is followed in all over the industry. So these are the design principles involved in cloud. So the first one is that implement a strong identity foundation. Second one, enable traceability. Third one, apply security at all layers. Fourth one, automate security best practices. And fifth one, protect data in transit and at rest. Last one, but not least, the prepared for security events. So first one, so what is meant by implement a strong identity foundation? So here, we have to implement the principle of least privilege and enforce separation of the duties with appropriate authorization for each interaction with your AWS resources. And you can be able to centralize the privilege management and reduce or even, eliminate the resilience or long-term credentials. So here, this is all about implement of a strong identity foundation. And the second one is that enable traceability. So here, we have to monitor, alert, and audit action and changes to the environment in real time. And we can able to integrate the logs and matrices with systems to automatically respond and take action. So this is about enable traceability. Third one, apply security at all layers. So rather than just focusing on protecting a single outer layer, you can apply a defense in-depth approach with other security controls. You can able to apply to all layers. For example, if you take like edge network or VPC, virtual private network, cloud, the subnet, the load balancer, every instance operating system and application. So all those things you can able to apply the security. And next one is that automate security best practices. So automated software-based security mechanisms improve your ability to securely scale more rapidly and cost effectively. You're able to create secure architectures, including the implementation of controls that are defined and managed as code in version control templates. And next one is that protect data in transit and at rest. We can classify your data into sensitivity levels and use some kind of mechanisms such as encryption and tokenization where appropriate. Reduce or eliminate the direct human access to data to reduce the risk of loss or modification. And last one is that prepare for security events. So prepare for an incident by having some incident management process that aligns with your organizational requirements. We can run incident response simulations and use tools with the automation to increase your speed for detection, investigation, and recovery. So these are all some kind of design principles, and this is very, very important key aspects, or is an important part in terms of cloud security. And next is that we're going to see is about cloud security challenges. The security, as I told earlier in the unit one, if you have seen that particular video, you could be able to see there are so many security issues, which is almost, which is going rapidly around the world. The first one is that increased attack surface. Second one, lack of visibility and tracking. Third one, ever-changing workloads. Fourth one, granular privilege and key management. Last one, cloud compliance and governance. So the first one, increased attack surface. What is meant by increased attack surface is that the adoption of cloud technology expands the potential attack surface for malicious actors. Cloud environments often have multiple endpoints, including user devices, networks, and cloud applications, each representing a potential vulnerability. Now, attackers, they will be exploiting these kind of entry points to get unauthorized access. They'll be deploying malware or conduct data breaches. As more organizations move to multi-cloud or hybrid cloud models, they will manage the increased attack surface, which becomes a significant challenge. So, the transitioning from on-premises system to cloud platform often leads to misconfiguration, increasingly vulnerability to attacks. Organizations, may struggle to fully understand the complex cloud environments, leaving some security gaps. And automated security tools, configuration management, and regular vulnerability assessments are vital in protecting against these expanded threats. A security strategy must be incorporated both in preventative and responsive measures to address these challenges. Second one is about the lack of visibility and tracking. So what does it mean by lack of visibility and tracking is that in a cloud environment often present a lack of visibility and control over some data and resources. So this lack of transparency complicates monitoring, tracking, and managing assets across multiple cloud service providers. Without visibility, organizations face difficulties in detecting and responding to unauthorized access, configuration errors, or compliance breaches, which jeopardizes security postures, limited to insight into cloud activities, which increases the likelihood of understand threats and vulnerabilities. And next one, in organizations, if you take we have to struggle to achieve some sufficient oversight due to complexities in integrating cloud services with existing security frameworks. And cloud security demands real-time monitoring and logging solutions to provide end-to-end visibility by employing analytics and AI-driven tools. So here, if you take AI-driven tools, Businesses can enhance the ability to detect anomalies, track user activity, and ensure compliance with the security policies. The next one is that ever-changing workload. So ever-changing workload is nothing but the cloud environment, it is dynamic with the workloads frequently shifting between different providers and geographic locations. So this rapid change presents security challenges as protection measures must adapt to varying configurations and threats, ensuring consistency, security across diverse workloads requires automated security solutions capable of scaling and adjusting with the evolving landscape. And the traditional security practices may not suffice for such agility or flexible approaches. So the security solutions, what they'll be doing is that they can able to protect the workload regardless of the location or state, or they can go for some microservices architecture or containerization. This is followed in Kubernetes and often results in some security teams. And by using some continuous integration and deployment with the CI/CD pipeline, are we able to do the security check to maintain the defense as workload evolve. And next is we are going to see is about granular privilege and key management. So granular privilege and key management here, what they'll be doing, they'll be managing the granular privileges is critical in the cloud security. So assigning some appropriate access level and managing encryption keys prevent unauthorized access and data breaches. So identity and access management, that is IAM solutions, are essential to define and enforce some fine-grained access controls based on the roles and responsibilities. And next one is that cloud compliance and governance. So here, the cloud compliance involves adhering to regulatory standards and industry best practices. Governance ensures that cloud operations align with the legal requirements and corporate policies. Complexities arise from navigating diverse regulations across regions and industries. Maintaining compliance in dynamic cloud environments requires continuous monitoring and adaptation to evolving regulatory changes. A clear governance structure simplifies the management of security policies, audits, and risk assessments. So organizations, they'll be facing some challenges in mapping some cloud configuration to the compliance framework. So in order to overcome such, implemented automated compliance tool, I can go for some tracking and demonstration to the standard. So an ongoing governance framework supports maintaining compliance posture and preparing for audits, which reduces the risk of non-compliance and governance. So this is all about the cloud security challenges. The next one we are going to see is about the types of cloud security solutions. So these are the types of cloud security solutions. The first one, security information and event management. Security information, that is called the SIEM, SIEM. And second, cloud workload protection platform, that is CWPP. And the third one is that cloud security posture management, that is CSPM. And next one, cloud infrastructure entitlement management, that is CIEM. And next one, cloud native application protection platform, that is CNAPP. And last one is that data loss prevention. So we will see what's meant by all those things. So the first one, SIEM, that is SIEM, Security Information Event Management. So it provides a real-time analysis of security alerts generated by the network hardware and applications. And the SIEM selects, or the solution which collects, correlate, and analyze the event data from multiple sources, offering a view of an organization's security posture. By centralizing the log management, SIEM tools helps to detect threats, investigate incidents, and ensure regularity compliance. So they play a role in identifying threats and responding to security events. So this SIEM systems utilize some AI and ML, that is machine learning, to detect some anomalies to reduce the false positives. They also enable some security teams to automate responses to known threats and streamline the incident management process, which integrates the cloud services, expands the coverage of threats across hybrid and multi-cloud environment. So effective use of these SIEM enhances the security, situation awareness, and accelerated response to the breaches. The next one is that CWPP, that is Cloud Workload Protection Platform. So here, so here in CWPP, it safeguards the cloud-hosted workloads such as VM, containers, and serverless functions. And CWPP provides visibility, vulnerability management, and runtime protection to ensure secure operations across heterogeneous environments. They also address the specific cloud workload threats, including misconfiguration, software vulnerability, and unauthorized access. And this CWPP, it offers some real-time threat detection and automatic remediation capabilities. And they also integrate the application layer security to protect the workload from exploitation. And this CWPP will be just what doing is that it will be continuously deploying by means of organizations can able to simplify the cloud security management and protect the workloads without compromising performance. The next one is that CSPM, that is Cloud Security Posture Management. So CSPM aid in identifying and reducing the risk due to the cloud misconfiguration and policy violations. This CSPM tool continuously monitor the cloud environments to detect the security gaps and also the non-compliance and deviations from the best practices which is followed. And this solution leverages a policy-based evaluation method. They examine the cloud setting and misconfiguration. They simplify the process of maintaining compliances with security framework by offering visibility into cloud resources and providing actionable insights for improvement. This CSPM implementation helps prevent breaches by proactively addressing vulnerability and ensuring security consistency across the cloud environment. The next one is that that is a cloud infrastructure entitlement and management, that is CIEM. This solution manages and identifying across cloud services. CIEM, it focuses on granting permissions and access rights. Uh, these tools will be helped to detect and resolve issues related to the access of permissions and privilege creep. By implementing CIEM, organizations can maintain control over who has access to what resources, ensuring identity governance and compliance. So this the CIEM solutions. It offers automated analysis of access policies and entitlement, simplifying the enforcement of least privilege principles. So the ability to audit and adjust some access rights dynamically. These tools support secure access management in complex decentralized cloud environments. And next one is that Cloud Native Application Protection Platform, that is CNAPP. So here, it addresses security challenges in developing, deploying, and operating cloud-native applications. They provide an approach by integrating security across the application lifecycle from build to runtime. So CNAPP focuses on container security, application security testing, and managing vulnerabilities. Like cloud native architecture like Kubernetes and microservice based application. It also aims to incorporate security in DevOps, ensuring continuous security application development and deployment. And by unifying multiple security aspects under a single framework, CNAPP reduces complexity and enhances security efficiency. It also enables organization to safeguard the cloud native application without slowing the development process. Last one, the data loss prevention. So this DLP is a crucial for protecting some sensitive data from accidental exposure or intentional exfiltration. So DLP involves identifying, monitoring, and protecting data in use, emotion, and at rest. So DLP solutions employ content inspection, contextual analysis, and machine learning to ensure data security. They can automatically block or encrypt data transfer that breach corporate policies, reducing risk associated with the data leakage. Integration with the cloud services that allows DLP tools to operate within the cloud environment, thus providing consistent protection. DLP strategies enable organizations to maintain control over the valuable data assets and mitigate that is reduce the risk of data breaches. So this is all about the types of cloud security solutions. So the next thing we are going to see is about comprehensive data protection. So what is by comprehensive data protection is nothing but it ensures confidentiality, integrity, availability of data across its life cycle, whether it is at transit, at rest, or in use. It also includes some strategies or technologies and the best practices to reduce the risks such as unauthorized access, data breaches, and loss, etc. So this is all about the comprehensive data protection. One of the key aspects of comprehensive data protection is that data classification and access control. So data classification and access control is nothing but we have to identify and categorize the data based on sensitivity. For example, it can be of public or internal or highly confidential, and we have to implement some role-based access control. And we have to give some least privilege principle to restrict the data access. And you have to use some IAM solutions like AWS IAM, Azure AD, and Google IAM. And second one is that data encryption. So in here, data encryption, encryption at rest, we have to protect the stored data using we have seen in the unit one, like basics of cryptography, like AES, SHA, DES, or TLS or SSL protocols. And we have to use some implement techniques like homomorphic encryption or confidential computing. So this is all about the data encryption. Third one, backup and disaster recovery. So here, backup and disaster recovery, you have to regularly automate backups to prevent the data loss. We have to implement some geo-redundant storage, that is we used to call as GRS for cross-region failover, and disaster recovery plans, that is DRP, and we have to do some periodic testing to ensure the business is continuing. And this is all about backup and disaster recovery. Next one, data masking and tokenization. So what is meant by data masking is that, well, so mask, as you know, we used to wear a mask, right? We'll be hiding a face. Similar to that, here in this particular cloud, we can able to hide sensitive data in a non-productive environments. So what is meant by tokenization is that nothing but replace the sensitive data with the non-sensitive equivalent tokens. So this is called as tokenization. Next one, data loss prevention. So data loss prevention is nothing but DLP. So monitor and control the data transfer to prevent the unauthorized leaks. We have to apply the DLP policies at network, endpoint, and cloud levels. We can also use the cloud DLP solutions like Microsoft Purview, Google Cloud DLP, or AWS Maxi. And next one is that compliance and regularity adherence. So here we have to follow some global compliance standards such as GDPR, General Data Protection Regulation, HIPAA, that is Health Insurance Portability and Accountability Act, and ISO 27001, Information Security Management System, and PCI DSS, that is Payment Card Industry Data Security Standard. And we have to implement the audit logging to track and report the security events. Next one is that threat detection and response. So by using the AI and ML based security analytics for protecting threat detection, and can able to deploy some intrusion detection system, that is IDS, and intrusion prevention system, that is IPS, connect real-time monitoring using SIME, which I've seen in the previous, that is SIME. Types of security like security information and event management tools like IBM QRadar or Azure Sentinel, Splunk, all those things comes under real-time monitoring. So this is all about the threat detection and response. Apart from that, there are so many comprehensive data protections where we'll be using some multi-factor authentication, zero trust security architecture, and end-to-end encryption. And we have to use some, we have to set up some temporary access control and data sharing policies to minimize those exposure. And so comprehensive data protection cloud environment is crucial for securing sensitive information and maintaining regulatory compliance. So by implementing strong encryption, access control, backup strategies, and real-time threat detection, organizations can reduce the risk by ensuring data security across all cloud-based operations. So this is all about the comprehensive data protection. So thank you all. I hope this video found to be very useful. Thank you.